Alright, and welcome to Graphing Rational Functions, Level 1. Now, in problem 1, it says graph the function f of x equals negative 1 over x minus 3 and describe the domain and range. In order to graph a rational function, you really need to know one of three things, okay? So let's kind of start with these in the order with which I think it's most important. Thing number one, you always want to look at the denominator, and your denominator will always give you your horizontal asymptote. Oh, I'm so sorry. It will give you your vertical asymptote. And you get this by always saying the denominator equal to 0. And really and truly, we could almost set it not equal to 0 because we're actually looking for the x that breaks the function. We're looking for the x that just doesn't work. Well, we do this by saying equal to 0 because we should know that we cannot do 1 divided by 0. That's a no-no. Okay. So, in order to do this, for the vertical asymptote, we add 3 to both sides, and our vertical asymptote is at x equals 3. So that means we go to the x-axis, 1, 2, 3 to the right. We'll put a point right there. And remember, this is called the vertical asymptote. It's perpendicular to the x-axis, and it just goes straight down that point. Very cool. Okay. The next thing you want to do is you want to find your horizontal asymptote. For a simple function like this, it's always the number that's being added here. Well, notice since there's nothing there, it's almost like saying plus 0. So our horizontal asymptote is at y equals 0. So we go to the y-axis at the point 0, and we know it's perpendicular to the y-axis, so you can see me just kind of shading like that. Okay, so what's the last thing that we really need to know in order to graph this? Well, we want to look at the sign in front of the fraction, and this is indicating to us that this is in fact a negative. It is in fact a negative function. So how in the world does a negative function work for a rational function? Well, it means that you actually reflect over the x-axis and you start in the lower right-hand quadrant formed by these two dotted lines, and your line is trying to get really close to that dotted line, and then it swoops up here and starts to get to this really close to that dotted line. Now that's the first part of this graph, and then you'll always find the other part of this graph diagonally from it. So it's really close to that dashed line, and then it swoops up, and it's really close to that dashed line. And there you go. We've graphed it. Pretty easy. Now the domain and the range are actually really simple. So for our domain, that's our x values. We're talking about going from left to right. Well, your domain is correlated to the vertical asymptote. So we know we had a vertical asymptote at x equals positive 3. So we say this. We say, hey, our graph is going to the left to negative infinity. So our domain is from negative infinity, comma. And as we go to the right, we actually approach this boundary. We approach this boundary at x equals 3 that we just cannot cross. And so then we say, okay, well, that's the left-hand side of the graph. And then when we pick back up on the right-hand side of the graph, well, we're down here on the other side of 3. So whatever you end with, you have to begin with in the next one. And then as we go forever to the right, we go to positive infinity. Notice these are the left half and the right half of the graph, and we join them together with something called the union. It means the union or the combination of both of these pieces. Okay, let's go ahead and switch to our red. And so I kind of use these colors backwards. That's okay. For our range, we're actually looking at the horizontal asymptote. Okay, and our horizontal asymptote was where y was equal to 0. So you can kind of cheat and just say, hey, it goes down forever, negative infinity, comma, and it's going to have a break right there at 0, union, 0, comma, infinity. So if you want to know where the graph breaks, you can always just look at your vertical asymptote and your horizontal asymptote, and that will give you that break point in the middle. Okay, now let's go ahead and look at one more example, and we can move a whole lot faster here. Okay, here we are in example 2. Now this time I'll keep my colors a little more consistent. So what is it that we're finding when we look in the denominator, the horizontal or the vertical asymptote? Well, we are looking at the vertical asymptote. And remember, you always set what's in the denominator equal to 0. So in this case, we can subtract both sides by 4, and our vertical asymptote is at negative 4. So we can go to the left 1, 2, 3, 4, put our point on the x-axis, and draw our dashed line. Okay, from here, let's switch to orange. we know that whatever constant is being added to the right, this will always represent our horizontal asymptote at y equals -2. So this is telling us to shift down 1, 2, and we're now at this height right here. Okay, cool. Now remember, the last thing that you really want to identify is what is the sign in front. And since we don't see anything there, well, we assume it is a positive. So this is in fact a positive function. We'll just abbreviate function. Okay, that means that it actually starts in the top right-hand quadrant, getting as close to that line as it can, and then it swoops down, getting as close to that line as it can. And it always reflects diagonally, so, or what we say is a 180-degree rotational symmetry. And there's our graph. Easy. Now, how in the world can we shortcut our domain and range? Well, our vertical asymptote, where we see x, is going to always be the breakpoint for our domain. So I can put my domain as -∞, comma, -4, close parentheses, union, -4, comma, positive infinity. And notice, like, we can see this. This graph goes forever to the left, it's going towards -∞. And as it goes forever to the right, well, it actually tries to get as close to -4 as it can, but it can't ever cross it. Okay, well, so we break with the union, and then picking back on the other side, okay, now we're on the other side of -4, and now we're going forever to the right, so obviously that matches positive infinity. Okay, now the range, we get the range from our y values. So theoretically, this thing should break at the value -2. And if it breaks at -2, well, it starts back up at -2 and to infinity. Okay, well, let's see if that's true. At the bottom of this graph, it's going down forever. And then as it goes up, it's approaching -2, but it'll actually never go past the height of -2. Okay. And then once we get to the other side of -2, okay, so it's getting as close to -2 as it can. Well, and then as we go up, 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 it goes up forever to positive infinity. All right, I hope this helps, and I'll catch y'all in our next video.